Hey everyone, in this video we're going to talk about univariate descriptive statistics. Univariate meaning one variable, descriptive meaning we just want to see what the data look like. We're not going to try to draw any conclusions, we just want to get a sense or an overview of how that variable is distributed. Our first tool is called frequency distribution tables. A frequency distribution table is a tool that is used for categorical variables. Categorical so we can use nominal variables, ordinal variables, or dummy variables. If you have a continuous variable, you need to turn that continuous variable into an ordinal variable or a dummy variable. I'll talk a little bit about how to do that later on in the video. The frequency distribution table is particularly important to help us take a large volume of data. We could have 100 rows, we could have 1,000 rows, 10,000 rows of data, and get it down to a manageable size for interpretation or an evaluation. Essentially what we're going to do with a frequency distribution table is look at each individual value of the variable and then produce counts and percentages for those values. Let's just jump right in and take a look at how it works. Okay, so here I've got some fictitious data. I used a random name generator that I found on the web to create some student names. I've got a variable called standing, which is the student's class standing, where 1 is equal to first year or freshman, 2 is equal to second year or sophomore, 3 is equal to third year or junior, and 4 is fourth year or senior. I also have the student's average grade in the class. Once again, these names are completely made up, and so are the class standings and averages. So let's jump into how we use the frequency distribution table. On the right-hand side, you'll see that I have a frequency distribution table started. I have a column marked X. The X column is for the values of X. I've got a frequency X column, which is going to be the counts. I've got a %x column, which is going to be for the percentage of observations that occur for each value, and a cumulative percent of x. So my first step is to list all of my unique x values. And you can see here that if I have 4 class standings, 1, 2, 3, 4, I'm simply going to list out the 1, 2, 3, 4. Once I've listed out those 1, 2, 3, 4s, I want to count the frequency of each value. So I'm going to count the number of 1s. There are 10. I'm going to count the number of 2s. There are also 10. I'm going to count the number of 3s, which there are 3 3s. And I'm going to count the number of 4s. There are 2 4s. Once I do all of this, I will fill in my frequency column, and I can total out that column. If I've done my counting correctly, the total should equal the total number of cases that I have in my data set. So here I've got 10 1s, 10 2s, 3 3s, and 2 4s. 10 plus 10 is 20, plus 3 is 23, plus 2 is 25, for a total of 25 observations or values. My next step is to take my frequencies and create percentages. This is easily done by dividing my frequency for each value against the total and timesing it by 100. Here I put up a calculator just to make the calculations a little more obvious. So 10 divided by 25 is equal to 40%. So I'll add in 40%. So there are 40% of all of my cases are 1s or first year students. 10, it's the same thing. So 40 of my cases are sophomores or second year students. 3 of my cases, or 12%, are juniors or third years. And finally, 2 of my 25 cases, or 8%, are going to be seniors. One of the nice things about percentages is that they should all add up to 100. So I add 40 plus 40 for 80, plus 12 for 92, plus another 8 gives me my total of 100. So I know that I've covered everything and done all of my counting correctly. Finally, the last column is the cumulative percentage, and all this does is it adds up the cumulative percent as we go down the list. So we have 40% are 1s, or first year students. 40 plus 40 are 80% of my students are either first year students or sophomores. We add in the 12, so 80 plus 12 is 92% are first year, sophomore, or juniors. And finally we add in the 8 for 100, which gives us a total of 100. You can, of course, use the value labels. So here I'm changing 1 to first year, 2 to sophomore, 3 to junior, and 4 to senior. Now, one of the other things I might be interested in, as I mentioned earlier in the video, is using a continuous variable in a frequency distribution table. If you try to do this just on its own, you're going to get a single row for each one of the unique values. So what we want to do is we want to turn that continuous variable into an ordinal or dummy variable. Here I'm going to turn the class average into a ordinal variable using our standard A, B, C, D, F rubric. So here, any grade that is between a 90 and 100 will become an A. Any grade between an 80 and an 89 will be a B. Any grade between a 70 and a 79 will be a C. Any grade between a 60 and 69 will be a D. And any grade less than a 60 will be an F. Of course, in statistical analyses, we can't use the essentially value labels or string characters, so we want to create a numeric version of the same thing. So for our numeric conversion, we'll use quality points. A's will be worth 4 quality points, B's will be worth 3 quality points, C's 2 points, D's 1 point, and F's 0 points. Once I have that numeric grade calculation, I can start creating my frequency distribution table. Here I'm going to create a new frequency distribution table, and once again with my x values, my frequencies, my percents, my cumulative percent. I'll fill in my 4s, 3s, 2s, and 1s, and my total. Then I need to do my counts just as we did before. So I'm going to count the number of 4s, I'm going to count the number of 3s, I'm going to count the number of 2s, count the number of 1s, and fill them in their corresponding values in the table. I'm going to do the same thing as calculating percent x's as the frequency of x divided by the total for each row. Finally, I'll calculate the cumulative percentages by adding down the columns in the row. So 16 4s, or 16 A's. I've got 52 cumulative percent, that's a 16 plus the 36 for A's and B's, 92% for A's, B's, and C's, and 100% for A's, B's, C's, and D's. Once again, for readability and interpretation of the table, we can replace the values of x with our labels for A, B, C, and D. Finally, because we have two different tables here, I'm going to add some titles for the different tables. The first table is a frequency or count of the class standing, so I'll call this table Frequency Distribution of Class Standing. The second table is a frequency distribution table of grades, so we'll also label this table appropriately. So once again, it's fairly simple to create a frequency distribution table. We're looking for the different values of x. In our first case, 1, 2, 3, 4, first year, sophomore, junior, senior. In our second case, the grades, which we end up converting from a continuous variable to an ordinal variable of 1, 2, 3, 4. And then we have our counts, percentages, and cumulative percent.